Today we'll talk about the error part. So first of all, we should know what is error. Error is basically the difference between true value and measured value. There are basically two types of error. One is called systematic error, another one is called random error. Systematic error is the error which repeats itself again and again for the same reason. To remove the systematic error, we have to add or subtract a particular value to the measurement. And the random error, it may arise due to different reasons. That is why to remove the random error, we have to take more number of measurements and then we have to take the average of all those measurements. Now in physics, there are two types of measurement. One is called accurate measurement, another one is called precise measurement. So what is accurate and what is precise measurement? Suppose the actual length of a rod is 5 centimeter. Now, by a group of students, the length of the rod are measured as 4.80 centimeter, 4.90 centimeter, 5 centimeter, 5.10 centimeter, and 5.20 centimeter. Now just look these values. They are very close to the actual value. Because the actual length of the rod is 5 centimeter and the length measured by these students are respectively 4.80, 4.90, 5, 5.10, 5.20. So they are very close to the actual value, but they are not very close to each other. That means their gap is not very close. This type of reading is called accurate reading. This type of reading is called accurate reading. Now what about precise? Consider another group of students measured the length of the same rod and their readings are respectively 5.98 centimeter, 5.99 centimeter, 6 centimeter, 6.01 centimeter, 6.02 centimeters. Now look these readings. They are far away from the actual value because the actual length of the rod is 5 centimeter. But their readings are respectively 5.98, 5.99, 6, 6.01, 6.02. But one thing notice here, these values are very close to each other, but they are far away from the actual value. This type of reading is called precise reading. So when a reading is very close to the actual value, but they are not very close to each other, this type of reading is called accurate reading. And when the readings are very close to each other, but they are far away from the actual value, this type of reading is called precise reading. So now, just imagine if any group of students take this type of reading, just like 5.01, 5.02, 5.03, 5.04, 5.05. So these readings are very close to the actual value as well as they are very close to each other. So this type of reading is called accurate and precise reading. So in physics, we always try to take accurate and precise reading. Now I'll give you one practical example. Suppose the length of a rod are measured as x1 equal to 6 centimeter, x2 equal to 6.1 centimeter, x3 equal to 6.2 centimeter, x4 equal to 6.3 centimeter, and x5 equal to 6.4 centimeter. So what will be the actual length of the rod? To find the actual length of the rod, we have to take the average of all those readings. So the actual length is x bar. Average, you have to take the average. So that will be x1 plus x2 plus x3 plus x4 plus x5 divided by 5. So that reading will be 6 plus 6.1 plus 6.2 plus 6.3 plus 6.4 divided by 5. So the value will be 6.2 centimeter. This is the actual length of the rod. Now we will talk about absolute error. This is very important for exam purpose. Absolute error. Now absolute error, it may be positive or negative, and we represent absolute error by the term delta x, and its formula is true value minus the measurement. Absolute error in first measurement, that is delta x1, it will be x bar minus x1. Similarly, absolute error in second measurement, that will be delta x2 is equal to x bar minus x2. Similarly, absolute error in third measurement, that will be delta x3 equal to x bar minus x3. And for fourth measurement, that will be delta x4 equal to x bar minus x4, because here x bar is basically the actual value or true value of the rod. And for fifth measurement, the absolute error will be delta x5 equal to x bar minus x5. Now just calculate the absolute errors. For first measurement, the absolute error is x bar minus x1, that will be 6.2, minus 6, that will be 0.2. For second measurement, that will be x bar minus x2, so it will be 6.2 minus 6.1, it will be 0.1. For third measurement, that will be 6.2 minus 6.2, so it will be 0. For fourth measurement, that will be 6.2 minus 6.3, it will be minus 0.1. And for fifth measurement, the absolute error will be 6.2 minus 6.4, so it will be minus 0.2. So now we'll find the mean absolute error. Now we'll find the mean absolute error. This formula will be delta x bar. And the formula of delta x bar is basically mod delta x1 plus mod delta x2 plus mod delta x3 plus mod delta x4 plus mod delta x5 divided by 5. So to find the mean absolute error, we have to take the mod of all this absolute error. That is why I told that it may be positive or negative, it doesn't matter. At the time of calculation, always we will take the magnitude. So what will be the value? That value will be 0.2 plus 0.1 plus 0 plus 0.1 plus 0.2 divided by 5. That will be 0.12 centimeter. The length of the rod will be x bar plus minus delta x bar. That means actual value and error. So we'll write these things as 6.2 plus minus 0.12 centimeter. That will be the length of the rod. True value and or actual value plus minus error in the reading. Now, for exam purpose, we have to know what is fractional error. What is fractional error? You have to remember fractional error, f dot e, is basically error divided by true value. And percentage error, what is percentage error? Percentage error is basically fractional error into 100. This is the formula for percentage error. So delta x bar divided by x bar into 100. This is the formula for percentage error. Now, at the time of solving numerical, they will give us the value with error and we have to find the fractional error or percentage error. So how we will calculate it? Let's take an example where the area of a rectangle is given 20 plus minus 0.2 meter square. So what is the actual value of area? The actual value of area is 20 meter square and error in the measurement of this area is basically 0.2. Okay. So the fractional error will be 0.2 divided by 20 because 20 is the actual value and 0.2 is the error. Now to find the percentage error, we just have to multiply this thing 0.2 divided by 20 with 100. This is called basically the percentage error. Propagation of error means how this error runs in the calculation. So basically for addition and subtraction, error is always added. Error is always added. What is the meaning of that line? Just imagine the length of a rod is given by L1 equal to 20 plus minus 0.2 centimeter and the length of another rod is basically 10 plus minus 0.1 centimeter. Now what will be the total length of the rod if you connect them in series? The total length will be total length after connecting them in series will be 30 plus minus 0.3 centimeter. So what is the rule? We just add the true value and true value, 20 plus 10, 30, and the errors. We add also the errors. Now if someone asks you find the difference in length between these two rods, then how you will calculate it? The difference in length is 10 plus minus 0.3 centimeter. Look here, to find the difference we have to subtract L2 from L1 value. So we subtract the actual value, that means 20 minus 10, that is 10, but at the time of calculation the error, it is always added. As I told you, for addition and subtraction error is always added. We have to remember that for addition or subtraction, okay, the error will always be added. For multiplication and division the rule is different. For multiplication, just imagine that the length of a rectangle is 20 plus minus 0.2 centimeter and its breadth is 10 plus minus 0.1 centimeter. So what will be the area? Area will be length into breadth. So we have to multiply these two values. So area will be length into breadth. So the actual value of area, that will be 20 into 10, that will be 200. But how you will calculate the error? Just add these two values. No. I just told you that for addition and subtraction, error is always added. But for multiplication, division and all type of calculation, error will not always be added directly. We have to use different rule. So the formula will be delta A by A is equal to delta L by L plus delta B by B, where L is basically called length and delta L is called error in the calculation of length, B is basically called breadth and delta B is called error in the calculation of breadth. Okay, so by using that formula we will be able to calculate A into delta L by L plus delta B by B. Now we can write delta A equal to 200, delta L means 0.2 divided by 20 plus 0.1 divided by 10. Now after calculating, we'll easily able to calculate this value. So let's say the value is psi. So what will be the area? The area will be, you have to write the answer in this way, 200 plus minus psi centimeter square. Okay. For division, how we will calculate? Let's say through this resistor having value 20 plus minus 0.2 ohm. Here 20 is the actual value of resistance and 0.2 is the error in the calculation of resistance. Suppose some current is flowing through this wire. As a result, the potential difference between its two ends is basically plus minus 0.5 volt. Now we have to find the value of current through this resistor with proper error calculation. So we all know from Ohm's law V equal to IR. So I will be V by R. So it will be, at the actual value is 50 divided by 20. So that will be 2.5. This is the actual value of current. Now we have to calculate the error in the measurement of current. So how we will calculate? So we have to take that I equal to V by R. Now the formula is delta I by I is equal to delta V by V plus delta R by R. So now delta I is basically I into delta V by V plus delta R by R. So after putting all the values, now that will be delta I is equal to 2.5, delta V is 0.5 divided by 50 plus 0.2 divided by 20. So let's say the value is star. After calculation, the value will be star. So the answer will be current flowing through this wire is basically 2.5 plus minus star ampere, where 2.5 is the actual value of current flowing through the wire and star is basically the error in the calculation of current. Okay. Now I will generalize all this formula to make it simple. Let's say few physical quantities, suppose A, B, C, D are related as A equal to B square C cube divided by D to the power half. So what will be the error calculation formula? We have to write delta A by A plus 2 into delta B by B plus 3 into delta C by C plus half into delta D by D. If few physical quantities are deleted as A equal to B square C cube, then we have to write delta A by A is equal to 2 into delta B by B plus 3 into delta C by C. It doesn't matter the power is plus or minus, always it will be in the plus formula. Okay, this is the general formula for calculation of error. Now let P, Q, R, S are the physical quantities which are related as P equal to Q to the power M, R to the power N and S to the power L, where P, Q, R, S are the physical quantities. They are the physical quantities. And M, N, L are basically the constants. So what will be the general formula? As I told you, delta P by P, that will be M into delta Q by Q plus N into delta R by R plus L into delta S by S. Now if we multiply 100 by both sides, then what it will be? 100 will multiply this side as well as we have to multiply 100 in this side also. So it will be delta Q by Q into 100 plus N into delta R by R into 100 plus L into delta S by S into 100. So just see here, delta P by P, this is basically error in the measurement of P, and P is basically the actual value. So this is basically the error, this is the actual value, error by actual value, error by actual value. So we can write this is percentage error in P, this is M into percentage error in Q, this is N into percentage error in R, and L into percentage error in S. So this one is also very important formula. This is called percentage error in Q, this is called N into percentage error in R, this is called percentage error in S. So we have to remember this formula very carefully. Now for solving numerical, you have to remember few things. Just imagine the radius of a sphere is given. Radius of a sphere is given 2 plus minus 0.2 centimeter. So we can write it R plus minus delta R, where R is basically the actual value of radius, which is 2, and the error in the calculation of radius is 0.2. Now the question is, find the percentage error in the calculation of its volume. We all know volume equal to 4/3 pi R cube. Now according to the formula, delta by V will be 4/3 pi into 3 into delta R by R. No, if you write the formula in this way, then that will not be correct. Why, sir? You just told that the power will be there and then we have to write delta R by R, this like delta V by V. No, this formula is valid for physical quantities. Physical quantities means any measurable quantity is called physical quantity. Actually, error arise only when we take some measurement, but in constant there is no error. So here 4/3 pi is basically a constant, so there will not be any error. Whoever the person, if he or she takes some reading, then there may be some error, but in constant there will not be any error. So the actual formula will be, that will not be the actual formula. So the actual formula will be delta V by V equal to 3 into delta R by R. Now if you just put the values, then that will be 3 into 0.2 divided by 2. To find the percentage error, we have to multiply both sides by 100. So the result will be 0.2 divided by 2 into 100. Now I think everybody will be able to calculate this value. So that value will be the percentage error in the calculation of its radius. Okay. So you have to remember one more thing, that error is always arise in the measurements where we take some readings, but in constant there is no error. Okay. Now suppose in the calculation of side of a cube, the percentage error is 2% and percentage error in the calculation of its mass is 3%. Now you have to find the percentage error in the calculation of density of the cube. So how we will calculate it? We know density equal to mass by volume. Remember, the body is cube. So m by L cube. Now we have to apply delta rho by rho equal to delta m by m plus 3 into delta L by L. Now just multiply both sides by 100. So that will be delta m by m into 100 plus 3 into delta L by L into 100. So that is percentage error in density, percentage error in rho or density. That will be percentage error in mass, and it is given 3% plus 3 into, that will be percentage error in the calculation of side, that is 2%. So the result will be 3 plus 6. So the result will be 9%. So this is the result. Let's take another example where the percentage error in the calculation of side of a cube is 3%. Now the question is, you have to find the percentage error in the calculation of its total surface area. We all know total surface area of a cube is basically 6L square, where L is called the side. So the percentage error delta A by A will be 2 into delta L by L. Now if you multiply both sides by 100, then that will be percentage error in area, and that will be 2 into delta L by L into 100, that means percentage error in side. So the result will be 2 into 3, that will be 6%. Why? Because as I told earlier, that there is no error in the constant value present in the formula. The error only arises where we take some reading. So that is the percentage error in the calculation of total surface area of the cube.